Hello everyone, myself Shrichana Datta and I'm a PhD student at University College Dublin. I'll be presenting our paper titled Retrieving Potential Causes from a Query Event on behalf of all my team members. So these are the key points that I'm going to explain to you throughout the presentation. Let's have a look how we got this idea. If I ask you to list down all the reasons behind assassination of Osama bin Laden, I'm certain that the first fact that comes up in our mind is Osama was killed by US missiles in 2011. But why exactly? What were the reasons because of which Osama was killed? So let's take help from Google. Let's see what Google says. So the first document that Google says is talking about the death of Osama bin Laden, and it's a Wikipedia page. This is certainly not the answer to our question, right? So let's see ahead. So rest of the following documents that is being retrieved by Google is also talking about the death of Osama. So none of the document is actually meeting up our query. So let's do one thing. Let's search more specific and change the query to assassination Osama bin Laden causes. Here we intentionally append the term causes with the hope that Google might be able to, list out all the reasons behind assassination of Osama. Okay, let's see what Google says. Here also, as you can see, we don't find all the list of documents that are talking about the causes, right? So things are now a little bit disappointing, right? So I'm sure most of us are thinking like, what if we had a system capable of finding out series of events that might have triggered the query event? Okay, thus we propose such a system named as Factored Causal Relevance Model, also can be abbreviated as FCRLM. So let's get introduced with Factored Causal Relevance Model and how it works. So given a query, FCRLM is capable of listing down all plausible events that might have set off the query event. As you can see over here, for the query assassination Osama bin Laden, the first document that is being retrieved by this model is an audio tape broadcast, which was sounding like the voice of Osama bin Laden threatening attacks against US allies, which is certainly a potential event that might have led to assassination of Osama. The second document is also talking about that Al-Qaeda is rebuilding and seeking to launch more attacks against US, which is also quite significant in this respect. So if you see all other document snippets, all the events mentioned here ought to be significant in terms of Osama's assassination, I'm sure. So all the documents that you see over here are annotated from ad hoc collection of file for our experiments. So let me now walk you through the architecture of our model. We propose a pseudo-relevance feedback model based on the assumption that causally relevant document, that is this set C, is likely to have only a partial term overlap with the topically relevant one, which is the set T. So if the query is bound drop, it is evident that in the top retrieved document set, most of the documents should be talking about either economy, prices, savings, etc., right? But in this case, our intention is to find all the documents that are talking about either Brexit or European Union negotiation, etc. So it is our intuition is to, our intention was like, it is quite likely that a number of documents beyond top ranks would indeed contain causal terms. So with this certain intuition, we use term distribution information from both these sets to build up a query with a broader aspect. And we favor those documents which comprise terms that have higher weights in C and lower weights in T. So technically speaking, we estimate a causal relevance model theta C as a function of the topical relevance model theta T, which represents a set of terms that are directly related to the core topic of the query. This eventually expands the set of initial query terms because a small number of initial query terms is likely not to have sufficient information to help find the causally relevant terms, and eventually the documents, of course. So we estimate a standard topical relevance model theta T with the help of this expression. You see, one thing we notice here is all the weights calculated here are actually capturing the co-occurrences between terms in the top retrieved M documents and query terms. Next, we consider that this estimated terms in theta T has the ability of making the query more general. which according to our hypothesis is more useful to find causal relevance. Here our intention is to balance the trade-off that terms in the causal model should be correlated well with the general concept of theta t and also should not be concentrated on solely the query-specific terms. Thus, we formulate causal relevance model theta t with this expression. Here we notice that we employ an odds ratio between the probability of a term occurring within a document retrieved and the probability of the same term estimated by this theta t, which are more specific to effect query event. Thus, we favor all the terms that are relatively infrequent in theta t through a decrease in the denominator, which is this, and frequent in the top ranked documents retrieved with a more general query through an increase in the numerator. And finally, we estimate our factor causal relevance model by substituting the topical model theta t in the second expression. But why we call it factor? Because the causal model is factorized in the topical, which then leads to estimating the causal one. Let's talk about the data set. So in case of collection, we used the telegraph dump, which was spanned across 2001 to 2011 from FIRE ad hoc benchmark dataset. And the whole collection was categorized into different categories like business, sports, opinion, etc. Total number of documents was around 300,000 documents, and the size of the vocabulary was more than 700,000. Well, while building up the queries, we actually compiled 20 different queries from FIRE ad hoc query set. And while preparing these queries, we set some thumb rules. The first one was each selected query event must have a number of factors responsible leading towards it. Secondly, we excluded all the cases where causative factor is either too obvious, that means all the causal relevant terms are already present in the query itself, or it's too small in number, that means in all those cases where we can find a list of or the series of events that might have led the query event. And lastly, selected topic must occur during the period covered by the target collection, of course. In terms of relevance judgment, I would like to show you the difference, how we actually judged all the documents. So for the same query assassination of Osama bin Laden, as you can see, the first document is actually talking about a buzz that Osama bin Laden may have died of typhoid in Pakistan last month. This document is essentially a topically relevant document, which is talking about the death of Osama, but this is certainly not related to his assassination, whatsoever. So but in the second document, in the second case, the United States blames bin Laden and his Al-Qaeda network for the September 11, 2001 hijack plane attacks on America. Is certainly a potential event that might have led to, the Osama's assassination. So let's talk about the evaluation. These are the baseline methods that we have applied. So firstly, we experimented with standard language model with Jelinek versus Smoothing. Next, we applied relevance feedback baseline method, which is vanilla RM3. And the third baseline method we used is the RLM with causal relevance, which is also abbreviated as CRLM. This is nothing but we actually swapped top n documents with a set of documents underneath, with the intention that the documents beyond the top retrieve ones would be useful to estimate causal relevance. For more details, I would like to request you to go through our paper. So this table actually shows the comparison of retrieval effectiveness between FCRLM, that is our proposed model, and all other baselines. As you can see over here, improvements with FCRLM found to be statistically significant. And this figure, this graphical representation actually depicts Spark query performance analysis in terms of average precision. And as you can notice over here, this yellow bars, these are associated with the proposed model FCRLM, has outperformed over all the baselines significantly for most of the queries. Just to summarize, in this paper, we have contributed a collection for causality-based ideal research. Also, we presented different notion of ad hoc search to find causal information of query events. And apart from all those, we propose an unsupervised pseudo-relevance feedback algorithm that relies on simply, but yet obviously effective heuristic that causally relevant terms are not directly related to the core topic of the query. Lastly, as a future research, we would like to explore ways of constructing causal chains of events in a recursive manner, which essentially means instead of outputting a ranked list of documents, we intend to extract events from the retrieved articles, treat them as queries in turn, and retrieve a list of further causes. Thank you. Thank you for your time.